Hello students, welcome to Unit 1 Notes, Section 1.3. This is our first notes for Unit 1. At this time, you can pause the video and answer these three questions, and then I will go over it. All right, so normally after students do this, after they do this warm-up, I would go over the answers that they came up with. I'm not really asking right now in class, so normally some things that they write down for point, line, and plane, when I ask them, what are your thoughts on this? They say, a lot of times they say a point is a place, it's a spot, it's small. They use a lot of adjectives like that. You might have some on your paper that resemble that same thing. For line, they tend to say straight. Some students will say never ending. Other students say thin or thick. What else would they normally say? Yeah, that's good enough for now. And then plane, a lot of students say, well, there are physical flying planes. Then they get more specific to talk about geometry, and they kind of get stumped. A lot of times they'll say in X, Y coordinate plane, because it's one of the only other places they've heard or seen it. Sometimes I like to use the word Cartesian coordinate plane, but XY coordinate plane is fine. Okay, so we are talking about that today. We are going to talk about points, lines, and planes. And I'm hoping that we understand the basic terms of geometry. Geometry is a lot of vocabulary, a lot of vocabulary, with a decent amount of algebra that goes along with it. So we're also going to talk about this word postulate and what that means. That's part of our vocabulary today. All right. So in geometry, we use words such as point, line, and plane, but they're undefined. So I kind of asked you a question that you couldn't really answer. I said, what do these mean to you? Write down your thoughts, but truly they're not defined. They're kind of accepted as descriptions. Okay, so we describe them, but they have no definition. So in order to define the words, you need to use words to further define them. So we can think of a point as being a location. Okay, it has no size, no thickness, it's not thick or thin. It's just represented by a location. So for instance, A is located here, B is located here, and C is located here. When we use it to describe the location or to name the location, we use a capital letter. We have to always use a capital letter when naming points, no lowercase letters. Okay, A, B, and C are all capital. And this area here that goes on forever, it's everywhere, that's called space. Okay, so you can think about outer space, it's endless. So is space in terms of geometry. So here, let's add a couple more. Let's put point D over here. Let's put point E right over here. Oh, sorry, E. I already did D. Let's put point F over here and point G over here. Cool. You just drew in some of your first points. Just make sure you use all capital letters. Okay. We can also write the word point F when we're talking about naming it. Okay. We could write it out like that. So if I ask a question, which is the lowermost point in this space, you would just say point F, and that would be your answer. The next one we're going to go over is line. So we can think about a line as this way. It's an endless amount of points that lies in opposite directions. So for instance, if I were to take point A, point B, and point C, there's also a point D maybe, and a point E, and a point F, and see how this goes on forever? And what it is, a line isn't a straight, thorough thing. It's actually a collection of points with points in between them, and points in between that, and more points in between that. And watch how I keep zooming in, and I keep putting points and points and points and points in between the points that are there. And next thing you know, you have this thing that we call a line. All right? And that line we can name. So again, it's an endless amount of points that lie to either side of a point. Okay, it extends in two different directions without end. So we use these arrows on both sides to just represent that it goes on forever. Okay, so how do we name it? Well, what we do is we name it like this, AB. This one is line AB, and it has a line above it. Okay, it's like a hat for it. AB has a hat. So this is the name of this line that's written down here. What's really cool, we can also name it BA, because in this case, direction will not matter. BA and AB both go in opposite directions forever. Therefore, no matter if you go from B to A or A to B, we're still going to go on forever in both directions, and it's still the same collection of points. Another name for this is called line T, lowercase t. So here's what's cool. When you name a line, you have to, and you cannot use any more, must use two letters. Must use two letters. You cannot use three. You cannot use one. The only time, oh, two capital letters, my bad. Two capital letters. The only time you're allowed to use one letter is if it's written in and it's over here or over here and it's a lowercase letter. So think about this. Nicholas, the name Nicholas. Sometimes you refer to that person as Nick. Nicholas is what I say when I say line AB or line BA. Nick, the nickname, is what I refer to when I'm referring to line T. It's kind of a nickname for it. So lowercase, it's a little bit less formal. Doesn't have the line above it. But what we do is we write the word line. We would never do this. We would never write this. This is bad. If you want to, do me a favor. Just do that and then cross it out so that you know never to write it that way with one letter. You can't write let's see, what are other ones we can't do? We can't name it A. That's wrong. We can't name it B. That's wrong. We can't name it T. That's wrong. What we can name it is line T, line AB, or line BA. Okay, so there's a little note to yourself. Hopefully I answered all those questions. Now those points that all lie here. So let's talk about point C and point D. Why not? All these points are what we call collinear. That means that they lie on the same line. So points A, B, C, and D are, my bad, give me one sec, are collinear. Why is it doing that? That's weird. I'm not sure why it's putting all those dots. All right, give me a second. Just trying to reset my pencil here. There we go. Okay. All right. So the last part here is a plane. So a plane is a flat surface. It has no thickness, no size, no shape, other than it kind of goes on forever. Think about it like a tissue that was flat on your desk. And that tissue, imagine it goes on forever in all different directions. It's the longest tissue in the world. It just keeps going and going and going. But it never curls, it never spins. It just goes on forever, perfectly in all directions from the surface of the desk. So it doesn't go down to the ground, it doesn't go up to the ceiling, but it goes on and on and on all around you in those directions. Okay, it's almost like taking a line and making a whole bunch of lines on it. So lines that go this way, and lines that go this way, and this way, and this way, and so on. So think about lines that are all on the same plane, like as if you had 15 pencils that you place down on your desk. They're all in the same plane, and the direction that you placed them, it's going in those directions all at once. Okay, so you scatter pencils on a desk, all of those directions, it's just continuous. It goes on forever. Again, no thickness, so think about it like a tissue, but going on in all directions based on that plane that you're on. And that's what we also call coplanar. So things that are coplanar are things like this, like points A, B, and C are coplanar because they lie on the same plane. So I'm going to add another point. So D is coplanar now. D is also coplanar. And you know what's not coplanar though? Watch this. I'm going to throw another point, Z. So Z is not coplanar. Look at this. I'm getting a little bit lazy. I'm going to put point. I should label it as a point, right? I just told you to do it, so I should be doing it too. So point D is also coplanar. Point Z is not coplanar. See how Z, I know it kind of looks, what I drew, I know what it looks like. It kind of looks like this goes on forever and it hits Z. And you're going to say, Mr. Ray, that hits Z. Let me put this into context. Here is your desk and Z is on the ground. Okay, so think about this as your desk and Z is on the ground. Do you now see why Z is not coplanar? However, if I somehow, sometimes it's hard to tell, like this right here, it might ask if it's coplanar. The question is, does it interact with the plane? Well, it might, but we're going to say that anything that's drawn on it is coplanar and anything that's not drawn on it, that there's a depth above or below it, making it not coplanar. Okay? It's hard because, yeah, these planes go on forever, so it looks like it hits Z. The question is Z at the same height and level, or is it down or up from that plane? The questions I'm going to give you on an assessment are going to be clear. Is it coplanar or is it not? And it's going to look like this, and it's going to look like Z is really far off and not going to be on that plane. Okay? All right, so take a look. Just one more quick review. Line, point, one capital letter. Line, two capital letters with a hat. Plane, three or more capital letters. So in this plane ABC, okay, now you're going to say, but Mr. A, take a look at this one, plane P. Okay, P is a nickname. Notice how there's no dot near P. It's not saying that that's point P, it's saying it's plane P. So you're able to actually use a capital letter, kind of like what you do with line. That was a lowercase letter. If you're using the word plane, you can label it with its nickname, plane P. So I don't want you to confuse. Point is one letter because it's a point, capital. Line is two capital letters because it's 2 points, not 3, not 7, not 1, but 2 points. Plane is 3 points or more. You can do 3, 4, 5. That's the most common. 3 and 4 is more common than 5. If you're going to call it by its nickname, you're going to write it out as point F, like this, one capital letter, one lowercase letter, line T, and then plane P with a capital letter. So those are nicknames. Okay? Hopefully I answered all of the questions regarding the language of what we're using. You're going to need it. Okay? So let's do a couple problems. Determine if the following sets of points are collinear. If so, name the line that they lie on. E, F, and C. E, F, C. All right. Well, let's look at E. Let's look at F. Let's look at C. What do we think? Collinear? Do they all go through the same line? Yeah, I think they do. So I'm going to answer this one. If so, name the line that they're on. So the answer to this one is yes, they are coplanar. Yes, collinear. And what's the line? I'm going to call it line M. I'm sorry, I just messed up. Line M, lowercase m. See how we have line M here? I'm calling it by its nickname. Or, here are more acceptable answers. Your answers could be, let's put, or. You could say, obviously the answer is always yes. Yes, collinear. But here's possible answers instead of line M. You could say line EF, that's a line. You could have said line FC, that's the same line. You could have said EC. Any two of the points, not three, any two, you can use. You could have also flipped these around. It could say CE instead of EC. That's fine. That's the same line. Okay, so there's a lot of possibilities. All right, let's look at EFD. Is EFD collinear? EFD. Let's try to draw a line through them. Nope. No, nope. Okay, so it's not going to be possible to draw a line, so the answer is no. But let me ask you, no, not collinear. What are they? They are actually, what does this look like? Kind of looks like a plane because it is a plane. Because this goes out forever in all directions and it encompasses anything that's written down there. So we could actually say that they are coplanar. No, not collinear. They are coplanar. Endpoints FPC. FCP. This one's close, but P is in the wrong spot. P needs to be up here or here along this line. So the answer is the same as before. No, not collinear, coplanar. Again, those are also coplanar. Same answer. Okay. What other questions do we have here? We have name line N in as many ways as possible. So N is composed of D, and C, and that's it. So CD is going to be the answer for this one, CD. Or we could say DC and switch the order around. But this is the same way. I mean, it's a different way, but it's the same line. But yeah, we'll list both of them. What I'm going to say on your quiz is list 2 unique ways. Well, it's not really possible to name this in 2 unique ways. You would need another point like R to be able to then do DC, CR, or whatnot. So the word unique is the word I'll use. I won't just say name it in as many ways as possible. I'll say name it in as many unique ways as possible. All right, name line L in as many ways as possible. Well, here we have E, F, and P, E, F, and D. So I'm going to say E, F. Let me use a different color. Let's do E, F. And you know what I'll do? I'll also do FE while I'm at it. And then, oh, I'm sorry. What is it? EP, EP, and D. My apologies. EPD. So we have EP, we have PE, we have ED, and line DE. Is it D? Did I get that right? Yep. E, P, and F. And then we have PD, and we have DP. So these are all the different ways to name line line L. All right, name line M in 3 other unique ways. So here I'm not going to repeat them. See how I repeated EP and PE? We're not going to do that. We're going to do M in 3 unique ways. That means I can't use the letter more than once. I can't spin it around and use EF and FE the same time. So it's going to be, let me do the other ones. I'll do the flip of what I put up here, okay? So I'm going to say FE. I'm going to say CF and CE. There we go. Why do you think the arrowheads are used when drawing a line or naming a line, such as EF? I already answered this one, right? The simple answer here is lines go on forever. In opposite directions. Let's keep it simple. That's the reason why. Okay, so now naming a plane. Each surface of the ice cube represents a part of a plane. So take a look. Here's the front. Here's the front here. It's A, B, E, F. That's the front. Here's the back. It's back there. Okay. Here's the side, the right side. Here's the left side. Here is the top. And here is the bottom. All right. So each surface of the cube represents part of a plane. Name the plane represented by the front of the ice cube. So I'm going to say plane. And how many letters do I need to use again for a plane? Take a second and think. All right, it has no nicknames. These are all points. So I need 3 letters at least. But I'm going to use 4. I'm going to say A, B, F, E. Okay, so ABFE is the plane I'm talking about. You know what? A lot of students ask, hey, Mr. A, what if I said ABEF A, B, E, F. My answer to that is it's not wrong. We normally do like to go in order because it helps us in the future with other questions. But the answer is you're not wrong. You could say A, B, E, F. You don't have to go in any particular order. We just try to keep it that way because it makes it easier when we go to do other things with it. So, all right. List 3 different names for the plane represented by the top of the ice cube. Why don't you take a second to do it? I'm gonna do I'm gonna do this on my own, and let's see if we got the same one. So feel free to pause at this time. I'm going to do a couple, and then let's see if we got the same ones. Remember, as long as it has 3 or more letters, it's a plane. You might have had the letters backwards from what I did, but that's okay, okay, because there's a lot of correct answers for this. So what is it? Represented by the top. Okay, H, E, F, G. So here's 3 I came up with real quick. Plane H, E, F, plane H, G, F, and plane GFE. And you know what? I'm HFGE, plane HFGE. I'm going to do one more. Plane HFGE. Why not? Just to show that you can jump around. Okay? There we are. All right. So, postulate. Postulate and axioms. Let's write the word axiom. Also, axiom. A postulate or axiom is what we call, an accepted statement of fact. So, a lot of the times people have opinion, and mathematics can be opinion based, but when we're talking about axioms and postulates, it's not about describing what's happening or an opinion on how to achieve an answer. It is what we call an accepted statement of fact, and that means that we need to start somewhere. How do we define what a pillow is? Well, if we all can agree to what a pillow is, then we can define a bed or a couch differently from a pillow. But if we all say that they're soft and fuzzy, or they're all filled with like soft material, or they're all filled with feathers or whatever, or cotton, we can't really get any further in our definement of it without describing it. So axioms and postulates have to be accepted statements of facts. For instance, 1 plus 1. So here's an example. 1 plus 1 equals 2. That's it. Done. It's accepted that 1 plus 1 is 2. It's not opinion. It might equal 2. It's not it may equal 2. It's not I don't believe it equals 2. It has to equal 2. So this is an accepted statement of fact. And now here's why this is important. It's not really about the 1 plus 1 equals 2, but how do we now define 3? 3 is 2 plus 1. So everything that stems from 1 plus 1 equal 2, everything that stems from that goes to something else. So without accepting this as fact, then we don't know what infinity is, or we don't know what a million is, and we don't know other things. So once we accept it, we can move on and start to accept other things. So let's take a look at our first axiom or postulate or accepted statement of fact. It says, through any 2 points, there is exactly 1 line. Okay. So let me prove it. I'm going to draw a random point here and a random point here. Can I construct a line through them? I just did. I proved this true. It doesn't matter where that point goes. Let me move it. Where is that point going to go? I don't know. Let's move it. Let's move the point here. Okay, fine. Trying to prove me wrong? That's all right. I'll readjust it. And now I have a line going through 2 points. So this will always be true. It's accepted. Through any 2 points, there's exactly one line. So you can now use this information. This is in your toolbox now. Line T is the only line that passes through points A and B. Yep, it's unique. You can see it there, and that's done. The next one, if 2 lines intersect, then they intersect at exactly 1 point. If 2 lines overlap each other and they lie in the same line, which you can barely tell I even did it, then they're the same line. We don't call them 2 separate lines. We call them the same one. But in this case, when 2 lines intersect, they intersect at point C. So lines AB and BC will intersect, AE and BD intersect at point C. That is accepted, always, always, always accepted. All right? And it's only one. It's exactly one. Okay. If 2 planes intersect, well, let's take 2 lines and let's expand them into planes. So take a look at this, and then take a look at that. And now you don't have just an intersection of one point, C. You have a point a point F, G, H, I, J, K, L, M, N, O, P, Q, R. And what happens is the planes go on forever, and so do the points. Well, what happens when you have an endless amount of points that lie in opposite directions? You have a line. So this one, plane RST and plane STW intersect at line ST. You will always have the intersection of a line when you have 2 intersecting planes. Okay, and I'm just going to quickly draw it in right here. That's your line ST. So you need to know this. You'll be asked on the quiz, where do 2 planes intersect? They intersect at a line. Okay. Last one. Through any 3 non-collinear points, any random 3, there is exactly 1 plane. So let me make 3 random points, and let me draw a plane through them. And you will quickly see that I am creating a plane and I now have a plane that will go on forever in these directions. And all 3 points lie on that plane because now this plane really, as it expands, has these 3 points and they're going on forever. As that plane grows, these points will look like they're closer together, but they're really not because they are we're zooming out and we're zooming out and they're getting closer, but they are still in that same plane. Okay, so let's find the intersection of 2 planes. Where does HGFE, the top, intersect with Oh, I'm sorry. I kept trying to change this color and I couldn't figure out what I was doing wrong. And BCGF. So here, whoops, I'm still doing it wrong. There we go. So where do these intersect? Well, when you do a little shading, you'll see that they actually intersect right here. And that is line GF. So what is the intersection? Line GF. Or I could say line FG. But those are the only two combinations I can use. Okay? And the next one, name two planes that intersect at BF. So now it's asking for the planes. So what I'm going to do is I'm going to erase this and we're going to actually put the planes in. I'm sorry, I'm going to put the line in. Then we're going to look at the planes that intersect at that line. Okay, so my suggestion, if you're going to write on your diagrams, just write lightly so you can erase them. So it looks like to me that you have this plane over here and this plane right here, the front and the right side intersecting at this line. So I'm going to say plane A, E, F, B, and plane C, C, G, F, B. All right. Take a second and look. You can pause it if you need to. Try to find out what these have in common. I'll give you a second. Feel free to pause. In the instance of keeping the time of the video down, though, I'm going to answer that question. So check this out. GF and FG shows up FG and FG. It's literally the only two letters that overlap. HG is unique and BC is unique from these two. Okay, what about BF? Where does BF intersect? Well, here's FB, here's FB. It needs to actually show up in that answer because if they intersect at a line, part of it is the line that makes up the intersection. So that is why you will see that repetition occur. All right. So this next one, we're getting to the end kind of. Here's example 4, shade a plane that contains A, B, and C. Notice they didn't stop at A, B, and C. They continued on to D because this plane goes on forever in all directions. So this is already answered. I just wanted to show you what it looks like. Notice you can do a horizontal or vertical or diagonal slice within these. So here's H, E, B, C. Okay, so H, E, and C were all included. They also included B, even though it wasn't written in the question itself. It's this diagonal that cuts it, kind of like cutting a ice cube diagonally, or like a margarine maybe, or butter. Okay, name another point that is in the same plane as A, B, and C. So here's A, B, and C. It is point D, right? That's also included. Name another point that is coplanar with E, H, and C, and that is point B. And that's what we were just talking about that I showed you. Okay? So now you're at the homework. You can begin this in class. You can do it, like I said, you can do it early, but I recommend, maybe doing a couple questions. Maybe do like just 1 and 9. Take one of each topic, just do it, see if you get it. And then when you're in class, you can do the rest. So you have something to do in class. And then you'll also have IXL content. Okay? So good luck. Hope this video was helpful.